You can smell the shrimp in it. Sorry, guys. It's shrimp pasta. Okay, here we go, my time. Here we go, my time. All right, today, what we're doing, we're starting a new chapter. It's all about equations of lines, and taking those two equations of the lines and finding the point where they cross the space. That's called the POI, point of intersection. POI, point of intersection. Did we all hear that? Now, there are 4 different methods that you can find the point of intersection. It's done by graphing, linear combination, substitution, and determinants. We're going to learn all of them. The first one today is going to be graphical. Okay? Now, graphically is the absolute worst method that you can use if you're doing it by hand. And the reason why is because our eye cannot see anything less than a ½ inch effectively. We can't tell if the 1/4 inch is actually a 1/4 inch or 1/3 of an inch or 1/8. Our eye cannot dissect that appropriately. Do we all understand that? So if you are doing it by hand, it's not the best method. If you're doing it graphically on the graphing calculator, it's great. You have no problems with that. Today we're going to learn how to do it by hand and how to do it graphically. Do we all understand that? Okay, now this is what your brain needs to understand today. Okay? Consistent means at a space somewhere they intersect. This is a consistent system. Look at my slopes. They're different every time, aren't they? Doesn't matter how, they are different. Yes? However, now they still intersect. I went from having 1 point of intersection to having how many points of intersection? Infinitely many points of intersection. Meaning they have exactly the same slope with exactly the same line intercept because they are essentially the same line. Do you understand that? Then we have train tracks. What can you tell me about those slopes? They're parallel, the slopes are what? The same, but the line intercept is different. Do we understand that? This 1 point intersection means, guess what? My slopes were different. Many points of intersection, everything was the same. And no points of intersection, only the slopes were the same. Now, let's talk about the word inconsistent versus consistent. Consistent means they physically cross. Inconsistent means they don't cross. They cross, they cross, they don't cross. You with me? 1 point of intersection, many points of intersection, no points of intersection. Inconsistent means no POI. Consistent means they do have a POI. Now, there are 2 types of points of intersection if you are a consistent intersection. You have the independent. Independent means you don't need anybody for 1. Independent means you don't need anybody for 1. I'm independent woman, I'm 1. Yes? Dependent means something relies on something. A child relies on a parent for food, clothing, accessories, and money, and all of that. Yes? That's an example of dependent. Dependent is whenever every single thing about the equations are exactly the same. You with me? Dependent means many points of intersection. So an independent system is 1 POI. 1 is independent. Yes. Independent person means it's 1 person. They're independent. Dependent means it's infinitely many points of intersection. Now, how do I write that you have infinitely many points of intersection? Please circle this, highlight it, do whatever you have to do. I am super picky about this, and I will mark it wrong on the test if you say Betty, and you don't tell me what the actual intersection point is. The physical intersection point is going to be braces, meaning it's the set. X comma Y is the ordered pair, isn't it? X is the X coordinate, Y is the Y coordinate. So this is the ordered pairs. The colon means such that it falls on the line 2x plus 5y equals -3. Meaning I want every coordinate, every ordered pair that falls on the line of 2x plus 5y equals -3. Do you understand that? Yes or no? That's what that means. That is an example of dependent, infinitely many. An inconsistent system is whenever they don't cross, their slopes are the same, but the y-intercepts are different, and that means there's no POI. Okay. Do you see this page right here? This is a super helpful page. Super helpful page. Like, this is the page that you really want to, like, imprint into your head. This is the page that you want to imprint into your head. So if I were you, I'd put a big box in the bottom right-hand corner of your notes there. This is the page that you want to remember. Okay? You are going to take every one of the equations that I give you today. You're going to solve every one of them for y. You know how last Friday we did a lot of solving for y? Okay? You're going to solve every equation for y. You're going to find the slope and the y-intercept of every equation. And then you're going to compare the slopes. If the slopes are different, then it's a consistent, independent, one point of intersection. Lovely little problem. You with me? If the slopes are the same, you then are going to compare the y-intercepts. And if the y-intercepts are the same, that means it's the same slope with the same y-intercept, which means it's dependent with infinitely many points of interest. Yes? However, if I have the same slope with a different y-intercept, that means I'm going to be parallel and they're train tracks. Do we all understand that? So, today, I want you to focus on telling me independent, dependent, or inconsistent. See those three I've highlighted? Independent, dependent, or consistent. I want you to tell me the number of POIs, 0, 1, or many, and then I want you to find the POI. And that's physically going to be a point, no solution, or infinitely many points. That is what your solutions can look like. Do we all understand that? It can be 1 point, such as 1, negative 2. It can be no solution, or it can be x comma y, such that x plus y is equal to 5. Okay? Are we all good on that? Yes or no? Okay, now, with that being said, let's go ahead and start this. Here's your first example. What did I say we were going to do with those? What are you doing? You can't take it out of my room. You can use the calculator on the computer. Yes. Okay, so what is the solution of the system? You're going to simply tear these apart. Negative 3x plus 2y is equal to 8, and x plus 2y is equal to negative 8. Solve each equation for y. So what do I do to the red equation on the left? Add 3x to both sides. So 2y is equal to 3x plus 8. Then what? Divide the left, the middle, and the right by 2. So y is equal to 3 over 2x plus 4. What do I want out of that equation? The slope, and what is the slope? 3 over 2, and what is the y-intercept? Ordered pair, please. 0, comma 4, because you can't graph 4, you have to graph the point 0, 4, correct? I know you know that, but you got to tell me you know that. Okay, now what? Let's do the next equation. Bless you. Subtract x from both sides. 2y is equal to negative x minus 8. Divide each and every term by 2, and y is equal to negative 1/2 x minus 4. What do I want out of here? What is my slope? Negative 1/2. What is my y-intercept? 0, negative 4. Okay, now before I move on to graph these two things, I'm going to ask myself this question. Are my slopes the same or different? So what does different mean? What does different mean? Means they're consistent, they're independent, and independent means 1 POI. Do we all understand that? So that's what I need your brain to go ahead and say. Okay, they're a consistent system. Consistent means I am actually going to cross, and I'm independent, meaning I'm going to have only 1 POI. And then we're going to physically find that POI graphically. So are you ready to do that? So let's go ahead and first graph the red left equation. How do I graph the red left equation? What do I graph first? The y-intercept is at 0, 4. And then from there, I'm going to use the slope, which is a positive 3 over 2, doing what? I'm going to go up 3 units and to the right 2, up 3 units and to the right 2. I'm going to do it again. Then I'm going to go down 3 units, 1, 2, 3, and to the left 2. Down 3 units and to the left 2. Down 3 units and to the left 2. Do you see how I have many points? On my first line, I want many points because I'm hoping that one of those points that I have on that specific line is an actual point of intersection. So we're going to go ahead and use our straight edge, which is our ID, and we're going to graph this line. Okay, now what? I'm going to graph the green line. So how do I graph the green line? What am I going to start at? The y-intercept, which is at 0, negative 4. And my slope is going to be up 1 and to the left 2. Up 1 and to the left 2. Oh boy, look what happened. Did I cross my line? I absolutely crossed my line. I don't need to graph any more points. You know why? I can physically see where this thing crosses each other. And it crosses right here. Can anybody tell me the coordinates of that point? It is the ordered pair 1, 2, 3, 4, negative 4, negative 2. That is the point of intersection between the red and the green line that I just did up there. Do we understand that? Yes or no? Make sense? Consistent means they cross. Do they cross? How many times do they cross? 1. So if you want to graph it first and then come back and tell me this, then do that. Independent means 1, and independent just means that they're a consistent system because they're intersecting. If the slopes are the same and the y-intercept is the same, then that means they're dependent and they have infinitely many points of intersection. Okay, that's that bottom right-hand side I told you that was super important. Okay, let's go to the next one. What do I do first? Separate them. 2x plus 4y is equal to 12. X plus y is equal to 2. How do I solve for y on the first one? Subtract 2x on both sides. 4y is equal to negative 2x plus 12. Then what? Divide the left, the middle, and the right by 4, and reduce each fraction. Negative 2 over 4 is negative 1/2 x. 12 divided by 4 is a 3. What is my slope? What is my y-intercept? 0, 3. Go to the second equation. What do I do? Subtract the x. So y is equal to negative x plus 2. And what is my slope? Negative 1. What is my y-intercept? 0, 2. Are my slopes the same or different? What does different mean? That means that it's an independent system with one POI. That's what that means, because my slopes are different. So now what am I going to do with that? I'm going to graph them, right? So if I'm going to graph them, I'm going to graph the point 0, 3. And then from there, I'm going to go up 1 and to the left 2. Up 1 to the left 2. Up 1 to the left 2. Up 1 to the left 2. Down to the right 2. Down into the right 2. Down into the right 2. You have no, you're good. Just graph that one. Okay, now green. Oh, I forgot to connect the dots. My bad. Okay, there's my line. Now let's graph the second line. The second line is starting at 0, 2. And I'm going to go up 1 to the right, left 1, up 1 to the left 1, up 1 to the left 1. Do you see how I already crossed it? I already crossed it. Can anybody tell me what my point of intersection is? What is the ordered pair? -2, +4 is my point of intersection. Do we all understand that one, yes or no? We good? Yes? Okay. Now, you don't have to graph these next ones. We're just going to go ahead and do them algebraically. I want you to take those two equations and tear them apart and solve for y. When I solve the first equation, I get y is equal to -1/4 x plus 3/2. The second equation is going to be -1/4 x plus 3/4. Are my slopes the same or different? What is the slope of my first one? -1/4. What's my y-intercept? 0, 3/2. What's my slope of my second equation? -1/4. And what's my y-intercept? 0, 3/4. Are my slopes the same or different? They're the same. So now, are my y-intercepts the same, making it the same exact equation, being dependent? Or are my y-intercepts not the same, being different, making it railroad tracks, being parallel lines? They're different. So therefore, this means that I'm going to have parallel lines, which means it's an inconsistent system. And how many POIs do I have? I have 0 POIs, and my point of intersection is no solution. Right? I don't intersect, so I have 0 POIs, and my point of intersection is no solution. Do we understand that? Okay, let's do the next one. Did everybody change the bottom one to 4x plus 12? Yes? What can you tell me? They are completely the same. The slopes are the same. The y-intercepts are the same. So what can you tell me about those two equations? How many points of intersection do I have? This is a dependent system, meaning I will have many intersection points, and the point of intersection I'm going to have is going to be x comma y. Why? Because I want every ordered pair, colon, and then pick one of the equations. For argument's sake, pick the top one. because it does not matter, does it? They're exactly the same equation. Yes? Bless you. Do we understand that? This is how you are going to do the first 6 problems. The first 6 problems are like all the ones that we've done before. Now, how do we deal with the graphing calculator? So, I want everybody to take these 2 equations and solve them for y. Take these 2 equations and solve them for y. I'm going to subtract 3 from the first one, 3x. Then I'm going to divide each and every term by -2. Positive 3 over 2x minus 6. Box that in. Did everybody get that for the first equation? Go to the second. 2x minus y is equal to 9. And what am I doing with that? I'm sorry? I could. There's many ways that you guys could do this. So I guess I should say you guys go ahead and do it because not everybody's going to think to do that right away. I would simply add the y over and subtract the 9. To me, it's the same exact thing, right? I subtracted the 9 and added the y. Okay? So you're going to get y is equal to 2x minus 9. Now, do you see these 2 things? You automatically know the slopes are different, right? So since the slopes are different, you're going to have one independent point of intersection, yes? So I want you to go get your graphing calculator. Are we ready? Pull up your graphing calculator and hit the home key. Everybody hit their house. The home key on the top right-hand corner. Everybody using my calculator? Okay, I want you to go to a graph, a new document. New document, do you want to save the unsaved document? No, you never want to save it. And we want to add a graphs page. Why? Because that's what we've been doing. Do you notice it says f1 of x? f1 is the same thing as y equals. You with me? So what was my first equation that I have to graph? The top one. What was the top equation that we graphed? So we're graphing is going to be 3 over 2x minus 6. So I'm going to type 3 division 2x minus 6. And hit enter. Do you see that? Hit tab. Tab allows you to pull up F2. And now we're going to type in our second equation, which was what? 2x minus 9. And hit enter. Now, watch. I want you to take your mouse. This whole thing is a mouse, remember? This whole thing is a mouse. So do you see whenever I move it over to the label, it actually says label? Do you see that? So move your mouse over until it hits the label, and then watch. I want you to hit Control, click. Do you see how it grabs it? And then just simply pull it out of the way. And then click in the middle and release. And you can do the same thing with this one over here. You don't have to do this every time. It's just if it's in the way. Control, click, and then move it out of the way. Do we see that? Yes? Now, here's the other thing. Let's say I can't see where my intersection point is at. So if I hit Control, if I get my mouse where I want it to be, and I hit Control, click, do you see how it turns a hand onto the page? And then I can physically pull the page into where the lovely intersection point is more centered for me. Do you see that, yes or no? And escape releases it. Again, you don't have to do those things, but those are some options for you to do. Now, everybody look at me. I want everybody to hit Menu. Analyze graph. And what do you think I want out of there? Intersection, which is number 4. Now, do you see that dotted line? Everyone look at me. This whole thing is a mouse pad. Go to the left of it and hit enter. Gently go to the right of it. Don't hold it down. You just have to simply graze across it and hit enter. What is my point of intersection? 6, 3. Do we all understand that? We're going to do it again here in a second. Nope. Nope. I'm going to show you what to do. So our point of intersection, this is going to be an independent system with one POI, and that POI happens to be 6, 3. Do we understand that? Yes? Okay, let's do it again. So what are you going to do with those two equations? Tear them apart and solve for y. So 2x minus 3y is equal to 7. 2x plus 4y is equal to 0. How do I solve this for y? Subtract 2x. Negative 3y is equal to negative 2x plus 7. Divide each and every term by negative 3. Y is equal to positive 2/3 x minus 7/3. Yes? Now what? Student speaking. I may have some from previous years, yes. We're working on one now, but yes, that'd be great. Can I get it to you later? Can I email it to you? Okay. Perfect. Thank you. Algebra first, and then simple geometry in a little bit. Okay. Thank you, ma'am. Bye. Okay, so on this one, you're going to have 4y is equal to negative 2x. So y is equal to negative 2 over 4x to give me y is equal to negative 1/2 x. Box that in. So now, go back to your graphing calculator. We already have stuff there, don't we? Watch. This is like getting a new sheet of graph paper. Hit Control, Doc. And what do we want? A graphs page. So now we have a blank sheet, don't we? And we're going to type the very first equation in there. So what was the very first equation? 2 over 3x minus 7/3. So 2 divided by 3, x minus 7 divided by 3. Hit enter. Yes? How do I get to enter my next function? Hit tab. And what's my second function? Negative 1 divided by 2 times x. Is that it? And hit enter. Can I see my window where they intersects well? Yes. But do you see these are kind of in the way? So I'm just going to pull that out of the way, and you can just land on it. You're okay if you can see it perfectly fine. It doesn't interrupt you. You're good. How do I find my point of intersection? Menu. Analyze graph. Intersection. Gently go to the left and hit enter. Gently go to the right and hit enter. And what is my POI? 2, negative 1. So I'm going to hit menu, analyze graph, intersection. Menu, analyze graph, intersection. Gently go to the left and hit enter. Gently go to the right and hit enter. And 2, negative 1 is going to be your POI. Yes? So I know that this intersects at one place, making this an independent system with one POI, and that POI is going to be the point 2, negative 1. Do we understand that? Okay, here's tonight's homework. I want you to do back from 7 through 12 first in class, so you guys have a little bit of time to use graphing calculators. If you don't have time to finish the class, how will you finish your homework assignment? Do the on a graphing calculator can do it. Now, problems 1 through 6, you need to graph. Problems 1 through 6, you need to graph. Here is graph paper. Problem 7 through 12 is a graphing calculator. Is there any questions on tonight's homework? Can we do it? Excellent. The rest of the time is yours.